Hey guys, how's it going? Welcome to day 6. Today we've been looking at a lot of secant lines. Today we're looking at secant tangent lines and the angles that are created, specifically the angles that when those angles occur on the circle. So let's take a look at what that looks like. As we remember, a secant line touches the circle twice. So here we see our secant. Okay. A tangent only touches once. Okay. And this angle is being formed right on the circle. So what I want to know is, how does this angle relate to this bend? And then how would this angle relate to this bend? Okay. So let's start with how we are going to figure this out. Now you may say, this kind of looks like an inscribed angle. Inscribed angles also had a vertex on the circle. And in fact, the rule is going to be the same as the rule for that. So let's take a look at how this works. Okay. So let's say that this angle, I like to use number examples first. Let's say that this bend here is 80 degrees. My question then, what is the measure of this angle? Well, we don't have any rules that work for this right now. Okay. And now that I look at it, I'm going to change that number. Sorry if you already wrote it down for 80 degrees. I'm going to change that number just to make it a little bit more accurate. I'm going to change it to 100 degrees. Okay. Now, if it worked like an inscribed angle, then this angle would have a measure of 50 degrees. And in fact, that's how it is going to work. But let's show you how we get there. Okay? To get this, we actually go back to our central angles. Okay? So I'm going to draw in the center here. The center looks like it'd be right about here. And what I'm going to do is I'm going to draw in 2 lines here. Now, what we remember, right, this is good review. What we remember about a central angle is the central angle always equals the bend. Now, remember, I told you that was a pretty easy one, but a lot of people end up forgetting it. So this central angle has to have a measure of 100 degrees. Okay. Now, since both of these are a radius, I'm creating an isosceles triangle. So this triangle right here is isosceles, which means I can figure out this angle and this angle, right? It's not the one I want, but it's getting me closer to it, right? I can do 180 minus 100. That leaves 80 degrees left for these 2 angles. I divide that 80 by 2, so I get 40 up here. And I get 40 down here. Now, what we have to remember is that there's a special property with tangent lines and radii. A tangent line and a radii that intersect at the same point always are always perpendicular. You can look back in your day 1 notes, and that was in there. So what I know is that this is 90 degrees, which means the other side is 90 degrees as well, right? If this is 40, what does this have to be so the whole thing is 90 degrees? Well, again, 90 minus 40 is 50. Again, that's the angle that I was looking for. How does it relate to the arc there? Well, it's half of that arc bend. So when you have secant tangent on a circle, we get angle equals bend over 2. And that's exactly the same formula we used for inscribed angles. Okay? Just to show you that this works regardless of the numbers that I choose, I'm just going to do a quick proof with letters here. So I'm going to call this bend X, and I'm going to call this Y. And again, what I'm trying to prove is that Y equals X over 2. Well, once again, I get this by putting in my central angle here. And this central angle, by definition, has to equal the bend. So that central angle is X degrees. Okay? And I know that this is a right angle because that's how radii and tangent line intersect. So first I'm going to get this angle right here. That angle right there, right? Think about how we got 40. We did 180 minus 100 and divided by 2. So now I'm going to do 180 minus X divided by 2. Okay, and that's for this part. The other part has to be complementary with it. So here's what I know. I know Y has to equal 90 minus 180 minus X over 2. Now that doesn't look like the right answer yet, but if I simplify this thing, I need a common denominator. What I get is Y equals 180 over 2 minus 180 minus X over 2. Once I've got the common denominator, I can smash these two things together, and I get 180 minus parenthesis 180 minus X over 2. I can distribute that minus, and I'm going to get Y equals 180 minus 180 plus X over 2. And my 180 and minus 180 cancel, and I get Y equals X over 2. I was able to prove that that angle there from the secant tangent lines on the circle is equal to the bend over 2. But again, here's how I like to remember that. All right, let's take a look at a couple of examples. Okay, here's my circle. Here's my tangent line. Here's my secant line. If I said this was 90 degrees right here, what would be that measure of X? And here's what I'd do. I'd say angle, hey, I know that's a secant tangent line on the circle. I know angle equals bend over 2. So what's my angle? Well, my angle is listed as X. What's my bend? My bend is 90 over 2. So I get X equals 45. Pretty simple. What if I asked you, though, to find this side? 2 markers. What about that angle? Well, there's 2 ways you could do that. You could say, hey, these 2 angles make a straight line. So I can just do 180 minus 45 and get Y equals 135. And I agree, that works. Okay. Another way to think about it is, hey, if this bend is 90, I'll use a different color. If this bend is 90, I can figure out that this other bend has to be 360 minus 90. 360 minus 90 is 270. And then I can say, hey, here's another secant tangent line. And I could say Y, the angle equals the bend over 2. And I could also get 135, that method of solving. Okay. Let me show you one more example and we'll be done. let's say that this angle right here is 30 degrees. What would that bend be? Well, if you say 15, you're not thinking about this correctly, okay? Because it has to be angle equals bend over 2. This time I know the angle is 30, so I'm going to say angle equals bend over 2. How do I solve for x? Well, now I got to multiply by 2, and I get that bend to be 60. So don't get in the habit of just always dividing a number by 2 or always timesing a number by 2, right? Think of the formula angle equals bend over 2, right? Sometimes we'll be doubling it to go from angle to bend. Sometimes we'll be cutting it in half, going bend to angle. Okay? That's it for this video. Enjoy the practice. Keep doing a great job. Keep up the good work. Talk to you later. Bye.